Okay, translations on a coordinate plane. So remember, if we are looking at a coordinate plane, it looks like this, where our x values go left and right and our y values go up and down. So if it tells us that a coordinate moved to the left, that means it went into the negatives. Anytime we move to the left, those are our negative numbers. If it moves to the right, then those are our positive numbers. So right is positive, left is negative. When referring to the y-axis, if we move up, those are our positive numbers. If we move down, those are our negatives. So up, positive, right is positive, left is negative, and down is negative. So those are the keywords you need to remember. Up is referring to your y, so that's the second. That's another thing. Sometimes in these, they flip them around. So always remember your x value comes first, y is second. So even in the phrase, if they say, like on number 3, it says 6 units down. So it gives the y value first. So this 6 units down is not going to go with that first number. It's actually going to go with the second number. So you just have to be careful on this worksheet to make sure you put the right adding or subtracting with the right x or y value. So like on number 1, write new coordinates if they are moved 3 units to the left. So that's talking about my x value because left would be on the x-axis. And if we go to the left, that's negative. So that would be minus 3 is how I would write that. And if we go up, that's the y-axis. So they put those in the correct order. And if we go up, that's adding. So plus 5. So when I add it to the old coordinates to make new coordinates, I'm going to say minus 3 from every x value and plus 5 to every y value. And then from there, I'm just going to add them or subtract them, however I need to do it. So A, to make a new coordinate for A, I'm going to solve it. So 3 minus 3 would be 0. 2 plus 5 would be 7. So there's my new coordinate for A. For B, 5 minus 3 would be 2. 7 plus 5 is 12. There's my new coordinate for B. Same thing on C. 7 minus 3 would be 4, and 2 plus 5 would be 7. Those are your new coordinates. That's it. That's all you have to do. Number 2 is the same thing. They put them in the correct order, 4 units to the right. So the going to the right are my positive numbers. So that would be plus 4 for every x value. So adding 4 to all of those. And then 2 units down. So that's the y value. And if we go down on the coordinate plane, that would be negative numbers. So minus 2. So you're going to subtract 2 from all of the y values. And when you put it in the calculator, you have to put it in just like you would see it. So negative 4 minus 2 is how that would look. Now 3 is where they kind of flipped everything around. They said they moved a coordinate 6 units down. That's the y value. So going down, like we said, that would be subtracting. So minus 6. So I'm going to go ahead and write that down on my y value so I don't forget it. 6 units down. So I'm going to say minus 6 from every single y value. Even though they wrote it first, they're talking about the y-axis, not the x. And 6 units to the right. Nope, just kidding. 8 units to the right. And if we go right or left, that's the x-axis. So right are my positives, so plus 8. So plus 8 on all of those first numbers. So then if we go to rewrite the new coordinates for D, negative 1 plus 8 would be 7. Negative 2 minus 6 would be negative 8. And there's my new coordinate. That's all we're doing. The new E, 0 plus 8 would be 8. 6 minus 6 would be 0. F, 2 plus 8 would be 10. And negative 8 minus 6 would be negative 14. And that's it. Number 4, they did the same thing. They said 1 unit up, that's talking about the y, and 3 units to the left, that's the x. So if we're going up on the coordinate plane, those are the positive numbers, so +1. If we go to the left, minus. So I'm going to say minus 3 from all of these x values and +1 on all of the y's. Number 5, they moved, 9 units to the left. Going to the left means those are the negative numbers, so -9. And if you go down on the coordinate plane, those are your negative numbers. So we're minusing both of them, subtracting both of them. So I'm gonna do the x values first. So 9 units left, so -9 from each of these. I thought, oh. They get tricky when there's decimals because the numbers get kind of jumbled up. So just be very clear when you're writing these down and make sure you include the decimal. Don't leave any numbers off. So negative 2.5 minus 9. Don't do minus negative. Just do minus 9. And that'll give you a negative 11.5. And then negative 4.5 minus 4, negative 8.5. Not minus negative, just minus. Then on Q, I've got 1.5 minus 9, negative 7.5, 3.5 minus 4, negative 0.5 or negative 0.5, either way, however you write it. And then for R, 6.5 minus 9, negative 2.5, negative 5.5 minus 4 is negative 9.5. I'm going to work out 6, and then I'll just kind of refer to these on the next few instead of working them out. But the decimal kind of tripped some people up today. So number 6, 4.5 units to the right. Those are, if we're going to the right, those are your positive numbers. So we are going to say plus 4.5. And if we go up, that's your positive numbers on the y value, so plus 1.52. So x values plus 4.5. I'm going to zoom way in. Plus 4.5 and plus 4.5. Do it all in your calculator. And the y values plus 1.5. Plus 1.5 plus 1.5 plus 1.5. Okay, so I'm going to rewrite those. I'm going to do it in my calculator. I'm not going to do it in my head. 4.5, nope. 4 plus 4.5 is 8.5. 5 plus 1.5. I don't care if you think you can do it in your head. Do it on the calculator just to double check. Okay, so those are my new coordinates for T. On U, 8 plus 4.5 is 12.5. 7 plus 1.5 is 8.5. And V, 11 plus 4.5 is 15.5. That's a point. And the Y value, 12 plus 1.5 is 13.5. Number 7, 3 units down. They gave you the Y value first, so be careful. 3 units down, subtract 3 from all of your Y values. 6 units to the left, that's your X, and those are negative numbers also, so minus 6 from your X's. Again, on number 8, they switched them around. They gave you the Y value first, but we're going up. That's positive, so plus 5. X values to the right, plus 7. So plus 7 first on your X's, plus 5 on your Y's. Number 9 is normal. 2 units to the left. Going to the left is negative. And then 8 units up. Going up is a positive thing. Plus 8 this 8 on my y's, minus 2 on the x's. Number 10 is nice. They gave you the x value first, then the y, and they're both positive, going to the right and going up, not going to the up. 11, if shape is rotated, it doesn't matter how it's rotated. If it's rotated at all, will its orientation and congruence change? Orientation, remember, is the direction a shape is facing. Congruence refers to the size of it, if it changes or not. So if something is rotated or turned, then the orientation does change. It's going to be facing a different direction. Yes. If you just turn something, if you turn yourself around, your size doesn't change. You don't get bigger or smaller. So no on congruence. Number 12 is the same thing. Don't worry about how it turned. It turned. So will the orientation change? Will the congruence change? If a shape is dilated, that means the size of it changes. It either gets bigger or it gets smaller. So will the direction it's facing change? Will its size change? Yes or no? If a shape is translated, that just means slide. Like literally sliding a piece of paper across the table, not turning it, not flipping it, not doing anything with it. When we slide or translate something, the orientation never changes. Okay, it's always going to be in the same, facing the same direction. So this one's weird because no, it moves, but it doesn't change orientation, and the size of it doesn't change. If a shape is reflected, that means flipped. Yes. No. 16, if a shape is dilated by a scale factor of 4, what will happen to its angles? Angles never change. Doesn't matter what the scale factor is, angles always stay the same. If you have a right triangle that's very tiny, and then we dilate it up times 10, and it's still a right triangle. It's still 90 degrees. Okay, so think of it that way. The angles will never change. The side lengths are what change. Depends on the scale factor. It either gets smaller if it's less than 1. I'm sorry. If the scale factor is less than 1, it gets smaller. If the scale factor is larger than 1, it gets bigger. The side lengths. And then true or false.